Okay, the Secondary Math 2 Unit 11 review, Systems of Equations. I recommend that you attempt all of these problems on your own first. Then come back and take a look anywhere you get stuck. If that feels like too much, take a look at number 1, pause the video, and you try to do what you can all by yourself, right? Then once you get if you get stuck, then watch the video until it catches up with that place, hit pause again, see what you can do independently. So the goal is to do as much as you can by yourself. This video is just to serve as a help for if you get stuck along the way where you could go next, okay? So let's start by graphing these two equations. I want to graph this one first. Remember that y equals mx plus b is a great equation for graphing lines. This is telling us that b is the y-intercept and that m is the slope. Okay, when you hear slope, I want you to think of a fraction, and we have the word rise over run. Okay, rise generally means up, run generally means to the right, but sometimes we have to go one of the opposite directions, so we'll talk about that in a second. Let's graph the first equation. Do you see its y-intercept at -2? And then its slope is rise 1, run 2. So we're going to, from this point that we just made, we're going to rise up 1 and then to the right 2, up 1, right 2, and we keep creating those dots. Now I'm going to come back to my initial y-intercept, and from there I'm going to go the opposite directions, both of them. I'm going to rise down 1 and run 2 to the left. See how it would still be a line? It still fits with the other dots, down and to the left. So if I go down and left, that's positive, just like up and right is positive. They have to both be opposites. Okay. Then let's try the next one. Y equals 3x plus 3. Maybe pause the video here and see if you can graph this equation on your own. The y-intercept is 3, and the slope is 3. And we can put a 1 under it to help us see how much to run. So we're going to rise 3, run 1. That's off the grid. I want to get some on the grid, so I'm going to change both directions. I'm going to rise down 3 and left 1, down 3 and left 1, and there we have an intersection. When we're solving these equations, that's the thing we're looking for, is the place where they cross. So right there is the point. I just have to name that point. From the origin, I go left 2 and down 3, so that's how I call it. -2, -3. Left 2, down 3. All right. Let's take a look at number 2. All right. The first equation is already in slope-intercept form, so find your intercept and your slope. The y-intercept is at -4. The slope appears not to be written, so it's really a 1, and we can put it over a 1. So we're going to rise 1, run 1, rise 1, run 1. And we can rise down 1, left 1. Okay. Now the second equation is a little bit harder. If we solve it for y, if we get y equals stuff, then we'll be able to see the y-intercept and the slope. So I'm going to start by subtracting 2x from both sides. Then I'm going to divide every single term by 3. Okay, my order is different a little bit, but the y-intercept is there, and the slope is the coefficient of the x term. It's multiplied by x. So my y-intercept is 1. And for my slope, I'm going to use the negative on the numerator. So I'm going to rise down 2 and then run to the right 3. Down 2, right 3. And I can go back to that intercept and rise up 2 and left 3. That would also be a negative slope, negative direction. Okay, we're looking for the place they intersect, and we've got it. It's right there. We can name that point from the origin as right 3, down 1, so that looks like 3, -1. Okay, This one is asking us to solve the system of equations using substitution. On the whiteboard here in the classroom, I've written that when you're doing substitution, you want to either get an equation that looks like x equals stuff or y equals stuff. That's what you want to start with when you're dealing with substitution. So right now, we have an equation already that is y equals stuff. So what I'm going to do is replace this y with what we know y equals, negative 5x minus 3. So I'm going to substitute negative 5x minus 3 for y. That's why it's called substitution. We're switching something different in. If you've substituted correctly and well, you're down to one letter now in the whole equation. See how that we don't have any y's to deal with in this equation anymore? So it's going to be easy for us to solve for x. I'm going to distribute the negative 5 to everything in the parentheses. Going to combine like terms. And then to solve for x, we'll divide by 29. 0 divided by 29 is 0. I need to find out what y equals as well. So I'm looking for the equation that says y equals. If there's one of those, that's where I'm going to substitute my x, because that'll be a fast, easy way to do it. So I'm going to do negative 5 times 0 minus 3. You can put that in your calculator if you're unsure, or you can do your math. This would be 0 minus 3, so our y is negative 3. If you choose to write it in an ordered pair, make sure that you put the x term first and the y term second. X, y, like alphabetical order. All right, number 4 is also requesting that we use substitution. Okay, so again, we want an equation that looks like x equals stuff or y equals stuff. Neither of them do right now, but there's a pretty quick way to make the second equation get there, right? If I add 2x to both sides, I will have y equals stuff, negative 8 plus 2x. Now, I'm going to put that in this equation where the y was. So it'll be 6x minus 3 times negative 8 plus 2x equals 7. Each time that we move forward a step, I suggest, again, that you would pause and see what you can do independently and then check it. So hopefully you're looking at this and you have an idea of what you want to do next. We're going to distribute the negative 3. So we'd have 6x plus 24 minus 6x equals 7. 6x and negative 6x, if I add those together, I would get 0. So if I simplify this equation as it is, I would have 24 equals 7. Variables are all gone. This is not a true statement, right? 24 is not equals 7. 24 equals 24, and 7 equals 7. So this is a no solution. If the variables are all gone, and I have a statement of a number that doesn't equal its other number, that's a no solution. If I had gotten to a place that said like 24 equals 24, or 0 equals 0, or 7 equals 7, well then that is an infinitely many solutions. But if I get to a statement like this, it would be no solutions. Okay, on number 5, they want us to use elimination. That's what's being requested. I put a note on the board about elimination that says here you're going to add the equations together and you want to get rid of one of the variables when you do that. So if I were to add these together, notice I have the x stuff lined up, the y stuff is lined up, the constants are lined up, equal sign lined up. So I'm just going to add right down. So I have 1x plus 10x, that's 11x. 1y minus 1y, that's 0. Negative 10 minus 1, that's negative 11. So just like that, I can solve for x. So elimination is nice because it goes quite quickly, quite fast. So now what I want to do is take this x equals negative 1 and I'm going to substitute it into one of the equations. And it doesn't matter which equation, we just have to make sure we do the math right. I'm going to choose that top one. So I'd have negative 1 plus y equals negative 10. If I add 1 to both sides, I will get y equals -9, and that's my solution. I haven't mentioned, but I should have, that you want to be checking your work, right? So each time after you finish, even from these graphing ones, you could plug in -2 for x, plug in -3 for y, and make sure that each equation works. It has to work in all of them in order for that to be the right answer. If it doesn't work in all of them, then that means there's been an error made. You need to go back and try it again. All right. There's another one that they're asking us to use elimination. So if I were to add these two equations together, I'd get 1x minus 2y equals 2. And that wouldn't be great because I would still have x's and y's. So not quite what I want to have happen. So in order to get rid of the x's or y's, I need to multiply. And in this case, I need to multiply both equations. If I were to get rid of the x's, I would multiply the top equation by 4 and the bottom equation by 5 so that I would have 20x and -20x. If I wanted to get rid of the y's, I would multiply the top equation by 5 and the bottom equation by 7. Then I'd have -35y and +35y, so the y's would go away. I'm going to go ahead and get rid of the x's. So I'll multiply the top by 4 and the bottom by 5. Let's do the top equation first. 4 times 5, that's 20x. Is that right? 40 and 36. Yeah, I think that's right. Okay, and the second equation. All right, we find that y equals 3. So if y equals 3, I want to plug it into one of these two equations and see what x equals. So let's see, if I did, maybe I'll use this one. 5x minus 7 times 3 equals 19. That would be 5x minus 21. Add 21 to solve for x. That's going to be 40. And divide by 5, we would get x equals 8. So when x is 8 and y is 3, we have the solution to this system of equations. Okay, these they're letting us choose any method that we want. Okay, so I want you to, take a look and decide which method do you want to use, and then how would you go about using it. These can actually be solved both ways, so I might do that. I might do it both directions. That would be some extra work for me, but if it would pay off, that would be worth it, right? So let's do substitution first. Okay, so I want to solve this top one for x. I want it to look like x equals stuff. So I'm going to subtract 7y. So I have an equation that says x equals -7y. I'm going to plug it in right there where the x is, right? Because we know x equals that stuff. That's why we're doing it for x this time. So 2 times -7y minus 8y equals 22. This would be -14y minus 8y equals 22. Combine like terms. And we'd get y equals -1. I'm going to substitute it in right there. So -7 times -1, we would get x equals 7. Okay, I'm going to try it again, this time using elimination. If I were doing elimination, I'd work on either getting rid of the x's or the y's. I think x would be easier, so I'm going to multiply the top equation by -2. That way, -2x plus 2x would be 0. So I will do -2x minus 14y equals 0. Then I'll add these together. and I get negative 22y equals 22. Divide by negative 22. And again, we would get y equals negative 1. Then we got to plug it in, so maybe I'd use this top one. X plus 7 times negative 1 equals 0. That's x minus 7 equals 0, so we would get x equals 7. 7, negative 1. Okay, let's try this next one. Okay. So if we started by using substitution, I would put this right there. So it would look like negative 2x plus 5 equals x squared minus x plus 3. Then I'd add 2x to both sides. We want to set this equal to 0 because we have a quadratic, this. So these are easiest to solve when we set it equal to 0. Okay, then we would factor a times c is negative 2, b is 1. What times what would be negative 2, but when we add it we get 1. I think it would be 2 and negative 1. So we have 0 equals x plus 2 and x minus 1. So our solutions would be negative 2 and 1. Okay, so I have two answers now that I'm looking for, two ordered pairs. Right? So let's take that negative 2 and plug it in right there. Negative 2 times negative 2 is positive 4, plus 5 is 9. Negative 2 times 1 is negative 2, plus 5 is 3. Okay, I'm going to show you how to solve using elimination, but it's going to, once we get right here, it's all going to be the same. So I'm going to keep all that lower stuff, just going to show you how I would do it differently up top. If you have a quadratic, that means something to the second power, and you're using elimination, get rid of the y's. The letter y, that's the thing we want to get rid of, okay? So I'm going to multiply this lower equation by negative 1 so that we'd have positive y minus y. That would be 0, right? So we get negative y equals 2x minus 5. Now I'm going to sort of ignore this and I'm going to add this and this equation. And we will get 0 equals x squared plus x minus 2, which is the exact same thing we got right there. So then we would factor, plug stuff in, and get the same answer. Okay, I'm going to start this time with elimination, and then we'll go back and look at factoring. So what I would do here is multiply this by negative 1. Because we have a squared, I want to get rid of y. So this would be negative y equals negative x plus 3. Then I would add the top and bottom equations. I'd get 0 equals 2x squared minus 4x plus 2. I would divide every single term by 2. That makes factoring a little bit easier. A times c goes at the top. Negative 2 goes at the bottom. 1 times 1 equals 1, and negative 1 times negative 1 equals 1. And I think it's going to be those, so that when we add them, we get negative 2. So our factors look like that. And we really just have one x solution then, don't we? It's 1. So we come back and plug it in. Suppose I plugged it into this equation. I'd have 1 minus 3, that's negative 2, and that's it. Okay, I'm going to use, go back and do substitution, but it'll keep all that lower stuff just as is. So I'm going to put this right there. That would look like x minus 3 equals 2x squared minus 3x minus 1. So I'd subtract x from both sides, add 3 to both sides, and I would get 0 equals 2x squared minus 4x plus 2, right? Same thing is right there, and then the rest is the same. All right, number 10 is kind of nice because y is -5. They already gave us half the answer. So to find x, we're just going to plug that in right there. 6x plus 8 times -5 equals -22. 8 times -5 is -40. Add 40 so that we can isolate x. Divide both sides by 6, and we get that x equals 3. Okay, substitution. Yeah, I wouldn't bother with elimination here because they've already provided that, so that was pretty easy. You could multiply this whole thing by -8 and then add it, and the 8s would go away. But yeah, either way is pretty nice. Okay, story problem. John caught 24 trout and bass while on a fishing trip. The total weight of his catch was 137 pounds. The average weight of a trout was 2.5 pounds, and the average weight of a bass was 8 pounds. How many trout and how many bass did he catch? Okay, the first sentence provides us with information about the numbers and types of things. So he caught 24 fish total. The fish types that he caught were trout and bass. Because T is sort of annoying to write in algebra, I'm going to call trout X, and I'll use B for bass. So if I add up all the trout he caught plus all the bass, guess what that equals? 24. So one equation is just about the count. The next equation is going to be about the weight, right? So notice that it says each trout, or the average weight of the trout, was 2.5 pounds. So to indicate that, I'm going to take every trout and multiply it by 2.5 pounds. Every bass would be 8 pounds. And then we have a total of 137 pounds. Okay, then you could solve here using substitution or elimination. They're both good candidates. I'm going to go ahead and do elimination this time. I'm going to get rid of the b. So I'll have -8x minus 8b equals, let me do 24 times -8, -192. And I'd get -5.5x equals 55, -55. Divide by -5.5, and we'll get 10. So that means he caught 10 trout. Okay, I recommend that you pause here and see if you can figure out how many bass. Because he caught 24 fish total, and 10 of those are trout, I could do 24 minus 10 to find out that the others, there's 14 bass. I could also substitute it into this equation, right? 10 plus b equals 24. Okay, let's do 12. If Isaiah has 91 coins totaling $7.15, and the coins are all dimes and nickels, that's not really a complete sentence, is it? How many of each coin does he have? I probably meant to put a comma there. Okay, if you've got dimes and nickels, how many total dimes and nickels does he have? 91. So that's just the count. If you add up all the dimes and all the nickels, it gets 91. The other one, it has to do with the value. How much is a dime worth? 10 cents. How much is a nickel worth? 5 cents. So that gives us our other equation, right? Let's use substitution on this one. I'll replace the d by subtracting n from each side. I've solved an equation for d. Now I'm going to put this right in that spot. 0.10 times 91 minus n, 0.05n 7:15. Negative 0.05. Okay, negative 1.95 divided by a negative 0.05 gives us 39. So Isaiah has 39 nickels, and if I substitute that right there, I can find out how many dimes he has. It's going to be 52 dimes. 39 nickels and 52 dimes. The Odyssey Rockets basketball team charges $5 for adult tickets and $2 for student tickets. Last night, they made $546 and sold 183 tickets. Pause here, reread it a couple times, and see if you can have some success. I'm going to start with just the count. They have a total of 183, and they're talking about adult tickets and student tickets. Then we have one based on the value. So 5A plus 2S equals 546. Okay, you can use substitution or elimination here. Pick your favorite. I'm going to do elimination. I'm going to multiply the top equation by negative 2 so that the S all goes away. Oops, 83 times 2, negative 366. So if I add these two equations together, I get 3A equals 180. Divide both sides by 3, and I find out that there were 60 adult tickets that were sold. If they sold a total of 183 tickets and 60 of them went to adults, then we know that the students must have had 123 tickets sold. Okay. Justin is skeet shooting. The height of the skeet is modeled by this equation where h represents height in meters and t is seconds after the skeet is released. The path of Justin's bullet is modeled by this equation with the same units. We need to find how long will it take for the bullet to hit the skeet. So they want to know length of time. That's going to be solving for t. And they're also saying that they want to know how high off the ground it will be, so that will be height. All right, I don't have a lot of space here, which is going to make this tricky, but we can solve this by substituting that there, or we could do elimination, making sure we get rid of the h's, right? So let's see, I actually want a lot of space, so give me just a moment while I write this down. Okay, sorry. H equals negative 5t squared plus 32t plus 2. H equals 31.5t plus 1. Okay. I'm going to add a page. All right, so all right, let's try substitution. So we'll plug that in right there. Okay, I like the coefficient of the quadratic term to be positive, but I think we're going to end up multiplying or dividing by other stuff anyway, so I'll just go ahead and move these two terms. I want to set it equal to 0. Since it's a quadratic term, that's how we typically solve those. If I multiply the entire equation by -2, then I can get this to be not a decimal anymore, which would be nice. And I'm choosing negative so that this will end up being positive. You could leave this problem exactly how it is and use quadratic formula and solve it, and you'll get there. But I want to try to factor. So a times c is -20. B is 1. I think we can use 5 and -4 divided by a. That would be 1/2 and -2/5. So those factors could look like t plus 1/2 and t minus 2/5. Did I make a mistake somewhere? Okay, so our solutions would be -1/2 and +2/5. -1/2 doesn't make sense. Go backward in time a half second, so we'll ignore that. And we'll just plug in 2/5 and see what we get. That's the same as 0.4, I think, if you want to put that in there. So 4/25, that's 16, I think, plus 2/5 minus 2. Oh, it's 8/5. I was wrong. 4/25. This is 8/5. I guess divide both by 5. Okay, so then that'd be 10/5 minus 2. 10/5 is 2. 2 minus 2 is 0. Oh, I didn't need to plug it back into that equation. My bad. So sorry. We need to plug it into one of our original equations. Sorry. I wish I knew how to edit so I could get rid of that, but I don't, I'm afraid. Okay, so we're going to take, maybe plug it into the second one would be easy. 31.5 times 2/5 plus 1. $13.6. Okay, so over there I've got time as 2/5 or 0.4 seconds and height as 13.6 meters. Okay, good luck on the test tomorrow.